b together. Okay? So if you wanted to find a y value when given x, and that's what this is done. Using the graphic calculator, determine the value of y when x equals 4.5. Your calculator knows how to take inputs. Right? To tell it an input, all you do is hit trace. You have to be on your graph first. Right? Looking at a picture of your graph, then hit trace, then hit 4.5, and hit enter. When you do that, you should get that y equals negative 16. Got some nods in the crowd, that's good. That's the easy one, right? It knows how to give you outputs. It knows how to receive an input. The other one's the trickier one, right? So if you're looking at question D, this is asking you to determine x when y equals negative 6.4. If you get given an output like that, you make it y2. So you're going to go y2 on your calculator. To do that, you go y equals. You go down to y2, and you type in negative 6.4. You don't want to do minus 6.4. You want to do negative 6.4. The negative is beside the decimal. If it's the first number is a negative, use the negative symbol. If it's any other number is a negative, use the subtraction symbol, just for future reference. Hit graph. When you hit graph, you should get a second line up here. Should look somewhere around here. So you should have your red line, so it's not colored like mine, but you should have a line like that, a vertical one going upwards, and then you should have a horizontal line now. That is where equals negative 6.4. Actually down here, no, well, it's 6.4, my bad. You want to figure out where they cross each other. Where they cross each other pictorially is right about here. Your calculator can figure that out by going second trace. After you go second trace, the fifth option is intersect. That's this intersection of two lines. So second trace, choose number 5. It brings you back here. It should say first curve, hit enter. Should say second curve, hit enter. Should now say guess on the bottom of your calculator, hit enter. And it'll tell you that at this moment, y equals negative 6.4 and x equals something that's tell me about that one. 9.3? Thank you. Alright, so when given an output, you draw a second line, second trace, intersect. Figure out where they cross each other. We're not going to verify. We could algebraically verify. That's where you put the numbers in, right? Like we did it in previous lessons. We just don't have time for that. Awesome. X and Y intercepts. So you can find X and Y intercepts using this calculator as well. I believe we're going to go back to the other equation. Let me just double check. Yeah. So go to your Y equals. In y1, we want to equal negative 1.25x plus 15. Right back to that first question we were working with. Negative 1.25x plus 15. You don't need y2 anymore, so you can delete anything that's in y2. Your window setting. We're going to have to put our window back to what we had it before. Okay, so those windows are right here. If we click window, this was your x minimum, negative 5. Your x maximum was 20. Leave your scale as 1, don't need to worry about switching it. Your y minimum was negative 10. Your y maximum was 25. So now everybody should have the original equation with the original window put back in. Awesome. Hit graph, just to make sure you have the right thing and it's working for you. So you should have that line that looks like this with the window that's somewhat similar to that one. You should have more ticks on yours most likely. Beautiful. We're going to find the x-intercept of this graph. Looking at the x-intercept, I can definitely see it, right? It's right here. That's my x-intercept. Your calculator can find it by choosing the right function. The function is under second trace, so it brings you back to that list. Another word for x-intercept, and one that they use in the higher grades, is called a zero. So if I say, what's the x-intercept, I'm also saying, what's the zero? That's just more terminology for it. You'll notice your second option on your list, 0. That's x-intercept. Click it. So when you click that option, it now brings you to your graph. It should look like this. And it should say left bound on it. Does it say that? Fantastic. The reason it's saying that is that in the future, you're going to have graphs with more than one x-intercept. And maybe you only want to find one of them. Right? So your calculator wants to know which one you want me to find. When it says left bound, it's saying, show me a spot that's to the left of your x-intercept. Looking at this picture, if I were to draw a line straight down, I went through the x-intercept, like that. I need to move my cursor to the left side of that straight line. I can only use the left and right arrows. Right? So using the left arrow, move your cursor to those on the left side of your x-intercept. That invisible line right there. When you're on the left side, hit enter. Now on the bottom it says right bound. So again, move your cursor to the right hand side of that invisible line using your right arrow. I click my right arrow to my cursor somewhere down here. I hit enter. It should say guess now. We never use the guess feature. Hit enter one more time, and it'll tell you exactly where your x-intercept is. For this question, it should now say this. That means that x equals 12 is your x-intercept. Your y value is 0, which we know because all x-intercepts have y. Okay, so that's second, trace the 0 function. Left bound, right bound, enter, enter. Not too bad, hey? That's one of the harder ones we do as well. To find your y-intercept is really easy if you just remember a trick. All right, so let's look down here for y-intercept, the next page. Determining the y-intercept. Here's the trick. What do we know about all y-intercepts? X equals 0. So what they're really asking you is what does y equal when x equals 0? Your calculator can take inputs really easily, right? All you have to do is hit trace, 0, enter, and it'll tell you where your y-intercept is. Way easier to find the y-intercept. But you've got to remember this little trick. Right? There's no feature for it. You just have to remember x equals 0 for y-intercept. Trace 0, enter, your y-intercept's at 15. You should have this in your calculator. Fantastic. I'm going to skip down here. These questions. Try the first one on your own. And so you're going to put this in your graphing calculator. The way you'd put it in your calculator is you'd put brackets around the 5x plus 15. So you go 5x plus 15 in brackets and then go divide by 3. Put that into y1. See if you can find the x-intercept and the y-intercept of it. Now, I'll give you a shot on your own and then I will talk you through it. If you finish that one, feel free to try B on your own.